Here we have the convex lens forming a real image, and I'm trying to work out a formula and to use the formula to find the image distance. So since this is the object and that is DO, is the object distance, here is the image, that's DI, and then since the focal point is here, that's the focal length. So assuming that DO is 30 centimeters and the focal length is 15 centimeters, we got to calculate the image distance and the magnification. So we use the distance formula for a lens, which is 1 by DO plus 1 by DI is 1 by F. And then when you rearrange that, you get DI is equal to 1 by F minus 1 by DO raised to negative 1. Okay? So because it's 1 by DI, we just make it DI and put it raised to negative 1. And the F here is 15. And notice that if it's a convex lens, the focal length is positive. But if it's a concave lens, the focal length is negative. That's a very important difference. So this being a convex lens, the focal length is positive. So it's 1 by 15 minus 1 by 30 raised to negative 1, which gives 30 centimeters. So the object distance is equal to the image distance in this particular case. And next we have to, another thing is, since you got DI to be positive, that means it's a real image. DI is positive. Yes, it's a real image. Now magnification. Magnification is negative DI by DO, and negative of 30 by 30 gives negative 1. So that's the magnification in this case. On the other hand, if we try to work out a problem that shows a virtual image, here is the DO, DI, and the F. As you can see, object is very close. DO is smaller than the focal length. I've shown the focal length on this side because the lens has focal points on either side being transparent. Okay, and this is DI. So definitely DI is bigger than DO. So assuming that it's the same lens, we're going to use the same focal length, but DO now is 5 centimeters. F is plus 15. We're trying to find DI and the magnification. Notice that DO is less than F. Okay, so it's very close to the lens now. Once again, we use 1 by DO plus 1 by DI is equal to 1 by F, and rearrange to make DI the subject as before. So 1 by F minus 1 by DO raised to negative 1. Focal length is 15. Object distance is 5. And when we do those calculations, we get negative 7.5 centimeter. So when you get DI as negative, that means it's a virtual image. It's a virtual image. Now, when you find the magnification, it's going to be a negative in the formula because it's negative DI by DO, and then you have another negative for the DI, which makes it positive. A positive magnification means it's a virtual image. So this is where you should not be confused. For distances, negative means virtual, but for magnification, positive means virtual. So now, if this is the case of a concave lens, no matter where you keep the object, you're always going to get a virtual image. DO, F, and DI are shown. That's the object, so that's DO. And here is the image, that's DI. And the focal point is right here, so that's the focal length. Assume that DO is 25 centimeters. DI is to be found. Focal length is 20 centimeters. We also got to find the magnification. Once again, the formula is the same. And then when you make di the subject, this is what you get. Oh, that's a mistake. I'm going to correct it. I got to put it as di. So it's going to be di. Excuse me for that. But when you do this calculation and assume, remember this is a concave lens. If it's a concave lens, the focal length is negative. The focal length is negative. So even though the problem says the focal length is 20 centimeters, when you put it into the equation, make sure you put f as negative 20. So negative 20 here. That's why it's negative 1 by 20. Negative 1 by 25 raised to minus 1. Okay, now I've corrected it. Di is what we're getting. You get negative 11.1. Then magnification is negative di by do. Two negatives make a positive. We know we're going to get a positive because it's a virtual image. Magnification positive means it's a virtual image. So you get 0.44, also showing that the magnification is less than 1. That means the image height is less than the height of the object. Do also remember that magnification is basically height of the image by height of the object.